First up, I'm delighted to introduce Olivier Allard, who's the Digitalization Director at Maya HTT, and he's joining us from sunny Montreal this morning, and nice and early for Olivier. Olivier is a mechanical engineer who's worked for the past 10 years in digitalization projects. He's a strong background in leveraging Industry 4.0 key technologies, such as Internet of Things, 3D simulation, and artificial intelligence. Working at Maya HTT for the past 8 years, he now oversees worldwide projects with key marine players, looking at millions of data points. Olivier, we look forward to hearing your presentation. You're going to cover the utilization of digital twins for fleet management and provide some case studies and learning from other industries. So great, looking forward to it. Over to you.
Thank you very much for the introduction, Tim. So today we're going to talk about a digital twin for your fleet. Basically, I'm going to run through a few of the aspects of what is a digital twin and how it can be leveraged within the marine industry. First of all, just want to take a minute to introduce who Maya is. So we are a digital twin pioneer. Maya HTT actually stands for Human Technology Transformation. So we've been at the core of it for the past 40 years we've been in business. We have a lot of smart people on the team, but if I look at to our experience capabilities, we've done a lot of data points deployment, airplane engines. We've been involved for the engineering aspects, a lot of simulation, as I'll talk about later on. But you'll see we'll also be involved into data collection project, which will be the key of what I'm going to talk about today. So the predicted digital data within the real-time data that we combine those two to create what we call the digital twin. Maya has offices in Canada, US, and UK. If you're interested, a few of my colleagues are part of the show this today and in the next conference day as well. So feel free to reach out to us. Without further ado, I'll tell you a little bit more about what we do to put you in a perspective and context. So Maya has been breeded from a DNA of design and simulation for engineering aspects. So we are coding, developing our own software, but we're also helping customers getting rid of their bad designs. That's basically the whole goal of what we're doing. We added throughout the years the IoT, AI, big data, everything we can do with the existing data that you have or the future data that you're looking for. This is what we are good at. Be able to do these two things, we've been really great at developing our own software, helping our customer develop some software, which included some automation and optimization capabilities as well. So we have a whole division that can help you with that as well. To be able to really take full advantage of what the data and the engineering capabilities we're bringing together, we also have a division called PLM, so Product Lifecycle Management, to really help our customer from design to the usage of the tools or the assets that they're generating with our help. Now, enough talking about us. Let's start talking about the marine industry and why we're here today. So really, when Maya looks at the future, we're looking at an industry for marine that needs to be sustainable. I think we see a lot of legislation being addressing the CO2, NOx emissions from all the boats. Those are things that you have to be considering. We have to be. The future of marine is also interconnected. The reason is clear. You have to have data that's onshore, offshore. It has to be shared. It has to be connected so that people can take informed decision based on those data. Like any other industry, cost effective is the name of the game. You have to be within those profitable margins when you're doing that trip, when you're building that ship. And these will be more and more competitive areas that you'll have to focus on. So we'll look at how we can leverage the digital twin capabilities to get there. And again, high tech, we see a lot of new technology coming in on the multiple platforms that you'll be using. The real question is, what is the level of technology that you need or that you have right now, and how will you be able to leverage it within the future? So flexibility will be a key differentiator for the successful companies and enterprise within the marine industry. Again, I'll talk a little bit about that later down the presentation. So first of all, let's talk about the key control areas, things that you have control over your ships, your trips within all of your maneuvering and your operation of your boats and your fleets. So different things. If I start from the left here, we have the resistance, powering, seakeeping, maneuvering. These are all the things you're going to have to do throughout your operations, basically, of your boat, making sure that you reduce those cavitation erosion, so you don't want any of that rust or these rust problems. How will you be able to predict on these things? How will you be able to collect data on these things? These are going to be challenges you'll be facing next. And that's really where we want to see the digital twin helping you. Definitely aerodynamics, the drags, the wind loads, and the emissions that you're going to generate with your trips are going to be really important to look at in the future, and how can you optimize these on the future sense. So really the idea for us is to be able to collect data from each of these aspects, but also to be able to predict the behavior of your components or assets or systems in order to optimize each and every of these little aspects and KPIs that you're looking at and that you can control over time. So how do you do this? So at Maya, we've been doing simulation for the past 40 years, as I said. So those simulation can be translated in many different aspects. If I go around the clock here, we have, from the start, we have thermal simulations, fluid dynamics, which can be a key here. We'll talk about it in a second as well. Structural simulation to make sure all your assets are going to be able to withstand all the harsh environment they're going to go through. But then if we keep going, there are more and more that can be simulated. The idea that I'm trying to explain today, I won't go into a deep dive at each of those technology, but the idea is to say that you can use today's engineering capabilities to predict the behavior of a given system or a component of a system, and being able to predict how this system will behave can help you optimize. Then you can start going into what we call those what if scenarios. You can start testing, what if I go faster? What if I go slower? What's going to be the impact if I change the angle of the hull? And all of these things. And really that's the intent of the first piece of a digital twin for me, really, is to gather predicted data and compare it to the live data that we have as well, that we're able to measure on the stream. So what does that mean, simulations in the marine industry? How can that be leveraged, and how can you guys take advantage of those capabilities on the engineering side? First of all, I'll give you an example here from a company that really helped their ship design, leveraging all these simulation capability. We're talking about 36% hull efficiency increase. That's nothing compared to a lot of capabilities that you have to augment your profit. But in fact, it was the hull efficiency design helped them save $3 million a year per ship. Nonetheless, what that means, and that translates into real hard dollars for your company, but that's only if you are able to modify the future hull design of your ships. Let's say you have existing ships that you already have, that you're already experiencing today, their efficiency. What can you do? So that's, again, another aspect where the digital twin can help. The real question is, how can you leverage your legacy data and system to increase your today's profit? And that's a key question we encounter a lot, because we see that simulation can help drive new savings, like I just explained. But in reality, you can't modify an existing boat. You can't change an existing system. So how can you take advantage of what you have today and do more with it? So that's really where the digital twin, again, comes into play. This can go into many aspects, but I'll try to put some lights on dark corners of this topic. So we see the digital twin as really something that can take place in three different typical aspects. So we have the design portion, where really we're going to define based on the customer requirements or based on your own requirements, the type of trips, the type of loads that you're going to transport with the ships. What are the shape, size, propulsion system of that boat or that ship? That's one aspect where you can start doing those simulations. You can start also collecting data. So if we look at the simulation data you've done, you can improve the hull design like we just defined, but then you want to make sure this works well as intended. So then maybe you're going to do some unit testing. You're going to start testing some systems, and you're going to compare those test results to the simulation data, being able to validate your simulation and being able to increase the the confidence level you have into the simulation and those what if scenarios and optimizations you're running into. But then again, as I said, if you don't have the capability to go back and change your boat design, what are you going to do? Well, the same kind of thing happens at the service level. So you guys are today having your own fleet. They're running, the boats are doing their trips every day. What are the data you can access today? What are the data that are available? Whether it's the temperature of the engine, the oil within the engine, whether it's the speed the boat is going, its location, what type of water is it in. These are all types of data that today's technology enables you to collect. So really, you can start collecting the data from your boats. And then from there, what you can do is start doing what we call machine learning or artificial intelligence predictions based on past data. So if you've been collecting enough data from a single boat, you'll be able to predict what the future will look like for that single boat. If you have a whole fleet and you've been collecting data from different size, shape, or different, let's say, purpose boats, then you could define, you can learn from those boats and be able to compensate for whatever gap of data you have, maybe on some older or more legacy boats that you don't have the data from. So that's, again, another way where you can start leveraging your existing data to compensate for boats you don't have data for. Again, the same type of data would apply for the manufacturing portion. So you'll do some quality testing, you'll have some manufacturing process. And again, you can compare what you've planned from what you're actually getting in real life and see if your initial model is good. You can start correcting that model so that next time when you're going again for another boat or another trip or another plan, then you have better data. So that's what we call really the digital twin, that we compare the real-time data to the predicted data and be able to learn on both sides. But if you've seen right now, there's different, let's say, combination of those real-time to predicted data that we can do. So we, with Siemens, we work a lot with Siemens in that portfolio, and then we call it the holistic digital twin. So if I try to put an image on this, so we have those different, the product design, the production planning, all of these aspects I've just described. The idea is that you can do a digital twin for each of these individual aspects, but the key here resides when you're able to connect data from your product design to your production. So if there's a shape on your boat that changes, you want your production planning to be addressing those changes. Same happens if there's a production change that happened from the initial design. You want to make sure that the product data collection actually takes into account those changes that were made into production. So really, this is the key here, is really the ease of transferring data from one digital twin to another to really make sure we have a holistic view. So really, if we're able to get the insight from the actual performance back to the product design, if we know how our boats are behaving today with the collected data, then we're able to inform our design, our future engineering designs, how we can make better improvements and how we can leverage this holistic closed loop digital twin, which is really what we're talking about today. If I keep going on that route of what you can do, I want to make sure I show you also examples. So there are people that are already leveraging such capabilities. CSL is a company we've been working with at Maya, deploying real-time data collection on their fleet. That fleet has been worldwide. So really the challenges were, first of all, track the data on the boat. Secondly, bring the data back to onshore the data centers or servers so that data can be analyzed. And then there's also the challenge of pushing back some data to the boats with the informed KPIs or decisions that are being made onshore. So really, this was the first loop of data collection, data analysis, and then, decisions, or at least recommendation, being pushed back to the captain on the ship. But really where the key comes in is where you're able to leverage not only the existing data, as I said, from the boats, but also the prediction. So really being also able to, for example, in this case, we had enough data from the past history to be able to identify drive shaft vibration issues, and then be able to see, not only from this boat, from different boats as well, if we see those parameters, those data coming back again, then we know a certain level of confidence how long we still have before the drive shaft fails. So these are type of things we can do based on real-time collected data, machine learning, and then putting it back with a comparison with the real-time data, always checking in, am I in a maintenance situation or not, and then be able to raise the flag early enough for you to act on. So that was one of the key examples we've done recently, but there's tons of more we could discuss if you have data. And if you don't have data, the first step I would say is start collecting such data. So if we keep going, a few things that can help you get to that Shipyard 4.0 that we're talking about, making sure you have the decision confidence you're looking for within the model. Again, those models can be based on past historical data that you analyze and learn from, can be based on simulation engineering data where you're trying to predict the future based on the input parameters you have, or the combination of both, which I believe is the holy grail of those models being created. Then down the road, you want to be able to explore some possibilities. So not only do you want to be able to see the model, but also input some new things. What if this boat would go faster? Would it save on gas? Would it actually emit less or more emissions at this point? The question is always, if I double the number of boats, will I be twice as fast? Sometimes yes, sometimes no, depends on your reality. You want to go faster, meaning you want a model that runs really quick. You want some things that runs within the milliseconds space today for some application, and some other could be a longer analysis time, and it would be okay as well. And in order to make better decisions, you want to make sure you're able to connect all of those data together. Another idea where we've seen people leveraging the digital twin, if you have enough data and enough engineering prediction on how the behaving of the boat will be, you can even go down the path of training your own crew before the actual boat exists, making sure that they practice their maneuvering and their seakeeping operation to really make sure that whenever the boat comes on, that learning curve has been dealt with already. Just throwing out ideas on a different field right here. Where are we coming from with all these digital twin ideas? We're not reinventing the wheels. If we look at what the manufacturing has been doing for the past years, really they called it closed loop operation simulation, but they were able to track their manufacturing enough that they'd be able to do some operation replay or some bottleneck analysis or what if analysis. So that's what we've been seeing in the past decades of what's being done in the manufacturing area. So that's the type of approach and processes that we're bringing into the marine industry, and we want to make sure you're able to leverage today. So if you have any questions regarding this, Maya can help you, no problem, defining what's the next step. Again, I wanted to put into an image what we're actually doing with the digital twin, combining the physical world and the digital world. And that's an example being shown in the manufacturing area where, first of all, they say you start collecting data. If we keep going, you store that data so you're able to, start building an historian approach to it. You want to transfer that data to the analysis, start to do these production replay, try to understand what happened. Same for you if you can do it with a trip. If you could see what the path of a boat was, or if you could see how much of wind loads were applied to this boat, you could learn so much and then try to define, is this a bottleneck analysis? Why is my boat not getting in on time? Why is my boat getting too much emission? These are the type of things you want to start looking into. So you're going to do the analysis. You're going to start to vary some parameters. Try to see, what if I do this? What if I do that? So what are the parameters that I can play with? Start to simulate some of the components, evaluate those simulations, make sure they're relevant and they're accurate. And then you start doing those what if analysis to find out what's the optimal combinations of parameters you can act on, and then make the adjustment in your physical world and so on. So that's really the optimization loop we're looking at. Again, just wanted to give you some example from other industries. So this is a plant here, a dairy plant that was looking to improve their tank size. So leveraging some of our technology, we were able to do multiple iterations of what if scenarios, leveraging their actual models, and then from there be able to find out that we could increase the range from 2 to 16% and then decrease the volume of their range from 8 to 27%. So being able to reduce the plant size or the tank size was relevant and important for that industry. That's where we focused on these objectives. For you, we could focus on other objectives. I want to keep on going as well, giving you more of a mechanical example. So we had wind farms here that were using the same approach, doing the digital twin of the product and the performance, being able to combine those two, comparing how the product is behaving compared to what it was supposed to, and leveraging those simulation and the real-time data to be able to identify the remaining useful lifetime of the engines or bearings within those wind farms. So ideally, you want to do the same type of approach on your boats, being able to predict how the bearings of your engines or how any other key components or systems are actually behaving and what the maintenance should be. Short but not least, in conclusion, I want to make sure you identify the digital twin as a comprehensive one, not only one system, but being able to oversee your whole fleet. Personalizable and adaptable, those are going to be the key components for you, and being flexible. As I said, iTech today is not iTech tomorrow, so you want to make sure that whatever you pick today will be able to be flexible for your tomorrow's life. So if you want to have more information, I'll put a QR code here for our website, so you can go and find more about it. And if you want to find me, you have my QR code here for the LinkedIn page if you want to reach out to me. So that's about it for today. Sorry for the quick ending, but I could see time passing by.
Thank you, Olivier. That's really great. And we have got a few questions, so thanks for leaving some time. It's the digital twin for in-service operation really takes data monitoring to a different level, and so it's fascinating stuff. So please do vote for the questions if you want to make sure the ones you want here are going to the top. But the first one's from Antonio. Thanks for the presentation. How does the continuous monitoring of structural integrity fit into the whole digital twin scenario?
Great question. So as I tried to explain, and in 20 minutes, it's really hard, but I could talk for hours. But if you're continuously monitoring an aspect, right now you're focusing on the structural integrity, then if you had, let's say, my idea is if you had a full simulation that was run within the design portion of that ship usage, you're able to leverage it down the road within the operation of that ship. So being able to compare, let's say, deformation, or if you had any loads or strain gauge that you'd have in there, you want to be able to compare those with what you were expecting in terms of the future life when you simulated it, and then being able to compare the real-time measurement with the expected simulated data to be able to compare those two and see, am I having deformation that are actually higher or lower than what I expected, and then trying to understand what caused that difference or between what you expected and what you measured is really the key. Once you find out what's happening, whether it's a good or bad thing, then you can start investigating how you can fix or address this situation.
Tremendous. Thanks, Olivier. Next question from Asli is, who does the data belong to for liability purposes? And is it possible to divide the phases of data transfer to be able to assess liability if it changes?
So if I understand the question is, who does the data belongs to? We've seen a lot of people that are in operation gathering the data. I think we all understand Google is a multi-billion-dollar company today, and the only thing they own is data. So if you're collecting data, you want to own that data as a ship operator. Now, if you want to be able to do better, you might have to share that data with subcontractors or people business analysis that can help you on that. But still, I think you want to keep the ownership of that data to make sure you can leverage it down the road for a digital twin aspect or future prediction, whatever that comes down to.
And so with that ownership goes liability, I suppose, if the data feed fails or the
There's many ways to actually address the let's say data feed fails. We have buffering technologies. We have other ways to go about it. So you can store the data at the edge level, whether it's on the boat or on shore, depending where the data is being collected. On the liability side, I guess, if you're referring to if a model would predict something wrong, who's got to be liable for this, then it's all about the engineering processes that were followed and I guess the contract aspect at that point.
Yeah. Okay. Thanks, Olivier. And just very quickly, if you can you run predictions on board?
So yes, we've seen technologies now that are running on the edge themselves. So when we're calling on the edge, basically we're saying where the data is being collected, some calculation can happen. So we're talking about what in our wording ROM, so reduce order model. So if you're able to have a low compute, so lightweight computing algorithm that could run easily, you can then put it on the boat, on board of the ship themselves. So you can have a captain or a crew that could leverage those KPIs being calculated on board if there's no internet connections going back to shore or things like that, which is a key challenge for the marine industry.
Great. Indeed. Okay. Thanks, Olivier, very much indeed for your presentation. That was fascinating stuff. As I say, a whole different level of data. But we'll thank you, and we'll. I'm sure if there are any remaining questions, you can be contacted via the platform.
Definitely.
Thanks very much.
Thank you very much for your time, everyone. Have a good one.